Welcome back, everyone. We're continuing our notes on free fall, and we're about 5 or 6 slides in. We're picking up in our part 2 of the online lecture with regarding maximum height. Well, if you think about it, if we have somebody, say, on the ground right here, and they're throwing, let's say, a football into the air, it's going to take a parabolic shape. It will be going up, or be moving positively part of the time, and then it'll be moving it negatively, or having a negative velocity. But right at the very peak, or that is the maximum height, there's my football right there. It's not a very good football. What's the velocity going to be? Well, regarding the y direction, the velocity is going to be 0. Because it's no longer going up or coming down. Now, of course, when people usually throw footballs, they throw them with a horizontal component as well. But let's just think of this as being thrown directly up and then straight back down. At the height, or at the maximum height, the velocity is 0. For that split second, our velocity is 0. Which means we can use this to calculate how long it takes to get to the maximum height by using our equation number 1. Final velocity is initial velocity minus acceleration times time. The assumption is that you would know your initial velocity, but this is going to be 0 meters per second. That's our maximum height. And we should know our acceleration. That's 9.81 meters per second squared. Of course, the negative out front indicates that it's negative. And then we can solve for our time, how long it takes to get to our maximum height. Again, maximum height, your velocity, that is your y velocity, or your vertical component of velocity, is going to be equal to 0 because it's no longer coming up or going back down. You can also use this to calculate how high up an object is going to go. Right here, we have, this was equation, I believe, 5 that we derived in the last chapter. Our final velocity right here, is going to be 0. It will certainly depend on your initial velocity, and we have our acceleration. We can use that to find our y displacement, our vertical displacement right here. Now, of course, this right here is really just our delta y expanded. But we can use the knowledge that at maximum height, the y component of the velocity is going to be 0 to find either the time to the maximum height or the maximum height itself of an object. Now, let's calculate maximum height, or how long it takes to get to a maximum height for a ball being thrown upwards. So we have a ball thrown upwards with a velocity of 40 meters per second. So that's our VI right here. That's 40 meters per second. And I'm writing it here because I want to emphasize, always write out your notes. Even if it's written right here, write it out. So we know that's our VI. Our acceleration. Acceleration is going to be negative 9.81 meters per second squared. And since we're regarding the maximum height, that's going to be, well, our final velocity is going to be equal to 0. That's the velocity at the maximum height right there, 0 meters per second. So the question is, what's the change in the y component? What's our change in displacement right here? If we take our 5th equation that we derived, that is the one that was on the very bottom of the previous slide, that's our final velocity squared equals initial velocity squared plus 2a delta x. That was the original equation. Now, for our purposes, we're going to be changing it a little bit because well, our acceleration is negative, so that's all the same, but we're going to have minus 2g, we'll call it, or the negative 9.81 indicates the g there. And instead of delta x, we're going to be calling it delta y because we're talking about the y component here. So let's rearrange this now so that we're solving for delta y, or our change in displacement. Well, I'm gonna add the VI squared to both sides. So it's going to be VF, I'm sorry, subtract it from both sides, right? VF squared minus initial velocity squared. And then how do we get rid of the 2 and the negative acceleration? Well, we're going to drop that down in the denominator on the other side of the equal sign. So it's going to be divided by negative 2g. So let's write this all out here. Delta y, our maximum displacement of our ball being thrown upwards. What's our final velocity? Well, that's easy. That's 0. So that's squared. So 0 squared is 0. Minus our initial velocity squared. That's 40 meters per second squared over 2 times, or you could put negative 2 times 9.8, or I'm going to put 2 times negative 9.81 meters per second squared. Again, that negative denotes that it's the whole value at the bottom is going to be negative. So I can put the negative out front or in there. Doesn't really matter, but it has to be negative. And part of the reason for that is because the numerator is going to be negative 2. So the negatives cancel out, and we have a positive total displacement. So what's going to be our total displacement, or our total maximum height? Right here. We have the negative value of 40 squared over 2 times negative 9.81. That gives us a vertical displacement at maximum height of 81.5 meters. All right, now let's ask ourselves, how long does it take to the ball to reach the maximum height? Well, again, to exercise good practice, I'm going to be writing down all my knowns. So my initial velocity is 40 meters per second. My acceleration is negative 9.81 meters per second squared. My final velocity, that is my VF, is going to be 0 because we're talking about the maximum height, so it's going to be 0 meters per second right here. And I'm also going to write down what I just calculated, that is my change in the y component, or my change in displacement. That's 81.5 meters. Now, generally, if you find a value of one answer, well, first of all, sometimes you'll need to use that in the next one, but generally speaking, what I try to do is find an equation that does not include this, because if I miscalculated this in the previous problem, then that would throw off my answer for this one. So sometimes it's necessary that you use the answer from a previous problem. Other times, or let me just say, if you don't have to, I recommend not doing it, because you might have made a mistake, and we don't want to do that. So let's just try to find one that we can use all our knowns in, and I think we can do that. What's our change in time? Well, we can find that by using our equation number 1 for kinematics. If you recall, final velocity equals initial velocity plus acceleration times time. Well, let's write that in terms of g. Final velocity equals initial velocity minus g times time. So let's solve it now for time. Well, I want to take my, I want to add my VI to both sides. So delta t is going to be VF. I'm sorry, I did that last time too. I'm going to subtract VI from both sides, aren't I? VF minus VI. And then to get the g out of there, I'm going to divide by negative g. That's going to equal time, or my change in time. What is that? Well, my final velocity is 0. That's easy. My initial velocity is 40 meters per second. And my acceleration, that's negative g, or it's negative 9.81 meters per second squared. So negative over a negative. And actually, you can think of it as this. You can't have a negative time. So if you're going to have a negative in the numerator, your denominator has to wind up being negative as well. So you're going to come up with a positive time. So what's our time? 40, or negative 40, sorry, divided by negative 9.81. That gives us a time, or a change in time, of 4.1 seconds. There we go. That's example 1. Let's move on to the next ones.